When you have an object subjected to some forces, and those forces are causing the object to accelerate, it is highly recommended to distinguish between those forces that are actually acting and the resulting force, which is ma. Why? Because by doing that, we actually simplify the way we look at the Newton's second law, which is summation of forces equals to ma. The diagram that has the actual forces is called a free body diagram, and the one that has the kinetic force, ma, is called the kinetic diagram. In case of cables, don't forget to include the tension in the cable, because I've seen a lot of students who forget to do that, in addition to a lot of mistakes that happen because the student try to work things physically in their minds and they come up with the wrong conclusion. And to avoid that, just ask yourself a very simple question. What does the cable do in each of the following situations? Here in A, the tension is preventing the block from falling down. And it does the same thing in B. It also prevents B from falling down. Here in the truck, the tension is trying to resist the motion of the truck. And for the load, it also prevents the load from falling down. And notice also that we have two tensions here, one at each side of the pulley. And note also, by ignoring the size and the mass of the pulleys, we will have the same tension within each single cable. So let's demonstrate how to make a free body diagram for a common example like this one. We start by assigning the directions of the acceleration. And then let's consider A. So we have the weight of A, the normal force, kinetic friction, and we also have the tension, and it acts to the right because of the weight of block B, which is trying to pull block A to the right. And as for block B, we have the two tensions that are preventing block B from falling down in addition to the weight. And before you move on with the solution of your problem, make sure that you validate the equilibrium in each side of the segment. So on this side, we have a tension here in equilibrium with an equal and opposite tension here. And on the other side of the segment also, we have the tension here, which is in equilibrium with another tension from the ceiling. And now we are ready to have our free body diagrams. So for A, the summation of forces is equal to ma, and for B also, the summation of forces equals to ma. And note for each free body diagram that the kinetic diagram has the same direction of the acceleration. So for A, it is ma times aa on the same direction of the acceleration, and for B, it is also the same. So for the top equation, we have the positive to the right, and for the bottom equation, we have the positive down.